Hello everyone, I've been promising to write a custom package manager for the customly compiled Linux distribution that we've been building within this series, and finally this day has come. So in this video we'll write a shell script that will be allowing us to download the packages from the Technical Linux repository with all the dependencies and then install them to the system that we have created, we have compiled from scratch. But essentially, this should also be working for essentially whatever Linux distribution, because the packages would be installed to user local and then the respective path to like bin, lib, and share, whatever folders there. But I just don't really want to pollute my host system by debugging the script. So I would rather go and download the monkey Linux and run this under the QEMU. And there, under the ISO, I would be writing the particular script and testing it. So that's essentially the way to go. But you can follow the steps just like I do, but you can also write the script on the host system and debug it there, but just be careful with polluting your user local folder. So the difference between the package manager that we're supposed to be writing in this video, as opposed to the existing one that is available under the Technical Linux already, is that the Technical Linux one, is specific to the Technical Linux distribution, which never leaves the inner RAMFS. So it just goes a little bit differently and has a whole lot of things that we don't quite need, because we are supposed to run this system from the either from the USB flash drive or from the hard drive, like I've been demonstrating in the previous video. So we just want to persistently set up the packages so that after reboot we have the packages. So that, although this is not going to be the case with the with the ISO, because I'm just using that for the demo purposes. And I could have done this, and I was actually doing this when I boot from the USB flash drive. I was writing the script, debugging it, storing it. But there, I cannot yet record the video because that's just a pure command line interface with no XX server or any graphics. So I just don't have an option to to record the video. Or probably I could have tried to record the frame buffer directly. Well, that could have been the case, but yeah, not yet the case. Okay, so let's start with downloading the monkey Linux ISO. So I can say wget https and github.com, my username, and monkey-do linux/releases/download tag 0.1 and monkey-do linux.iso. Okay, so it's been downloaded. Okay, and now I do QEMU system x86_64. I want to say no graphics because I'm going to be running this in the terminal. I want to use curses. I want to say cd-rom equals to monkey-do linux.iso. Okay. I want to enable KVM for faster virtualization and memory being set to 1 gig. Well, this should be fairly enough. So let's give it a try. Okay. So now it's loading as it was like on the real hardware. Okay, so we've just successfully booted to the monkey-do Linux repository. So let's run the whoami command to make sure, that we did log in as the monkey-do user, which is fantastic. So now we can create the file called PI, which stands for the package manager, and let's make it executable. So all plus X and PI so that we can run this. Okay, now let's open this using the VICI text editor, which I've created, so PI. And now we can do the actual stuff here. So the very first thing to do is probably to add the shebang. So we're supposed to be opening this file with the BusyBox shell. Then let's provide some essential variables. So first we need to define the tiny core Linux repository. Okay, and let's call it repo. It's going to be equal to http tinycorelinux.com/14.x, so using the latest version available by the time of recording of this video. The architecture x86-64, since we have the 64-bit system, and the tcz here. Okay. Then another variable is the download folder. So download folder, and just call it download, and this is going to be equal to /temp/packages, because I don't really want this to be stored after reboot, even if I run this, even if I boot from the real hard drive. So just to everything get erased every time system reboots, but the installed version would obviously be there anyway. And finally, we need the current working directory. Okay, and this is needed because we're supposed to be recursively resolving the dependencies, and every time we need to change the directory to the current working directory before doing things. Yeah, because otherwise, when we do some CDs during the fetch routine, we may find ourselves not in the parent working directory, but somewhere else. That would result in disaster. So we need to have the parent working directory, and this is going to be equal to whatever returned by the pwd command. Simple and straightforward. And finally, let's create a function to download a single package. Okay. So this would be downloaded a single package as it states, but it will also be resolving the dependencies for this particular single package. So I can create the function called fetch here. And here, first thing I want to do, I want to change the directory to the current working directory. So again, like this may be called recursively. So hopefully that makes sense. Now we need to make sure that the user did actually provide the name for a package. So I can say if, and if 0 is if the command line argument 1 is not equal to 0. This is what it says. In this case, we do our stuff. And otherwise, I just want to echo the usage. So usage is we are in the assuming we are in the shell. So pi, and let's say nano. Want to download nano text. That is from Tiny Linux repository, for instance. Okay, and also here let's provide the main driver. I just want to call fetch, yes, and $1, so getting the first command line argument that user would provide. Okay, and now what? Now we can just quit and try to run our Pi. Okay, unexpected finish. Let's have a look. Okay, and here we also forgot to check this close the string. Okay, unexpected else, line 17. Yeah, well, that's because let's do something here. Let's say just cd. Okay, so if I do not provide any arguments, it just tells me the usage. And if I say pi and let's say curl, for instance, it doesn't give an error because that's the way how the script is supposed to be used. Great. So let's get back and now start working on the main part. So it might have happened that we already have the file being downloaded, because one file may be a dependency for several packages, so it might be downloaded. In this case, we do not want to download it again. But before that, before checking that, we also need to make the directory and -p to create the parent directory if needed, and the download and slash and $1. That's whatever user has specified as the name for a package would be the name of the folder here. So if it happens that the file, say -f, if the file download and slash $1 under the folder that it has the name of the package. And if there is the file with the same name with the extension tcz, so if it is available, so that's the condition. If this is available, then I just want to echo package one is also already installed. So I can say package, and the name of the package is already installed. Okay. And otherwise, we want to download it. So I can say else, and just to close it with fi. Okay. So otherwise, we want to say wget -o, which stands for the output, so where we're supposed to be storing our package. So we want to store it to downloads, and then the name of the folder is equal to the name of the package, right? Then we want to download the .tcz package. And where to download it from? Download this from the repo and slash, and then the name of the package .tcz. And this should already be enough to see whether it works or not. Yeah, we will then add some line to delete the packages before we're running the installation. But yeah, for now we can just do this here. So say rm minus recursively and forcingly delete the download folder. And then we will be doing this by the end of the operation as well, but for now we just leave it as is. Okay, now let's try to run it. So I just say pi and curl, and we're connecting to the repository, downloading things. So let's list the temp packages where we're storing this. We have the curl folder being created, cool. And under the curl folder, we have the file curl.tcz being downloaded properly. Great. Now the next thing to download is the dependency file. So let's add that as well. So I'm going back to my source code, and here just want to paste this in, and here there is the file called .dep, right? So right quit, and we can do this again, like PICURL. Okay. And now if we list the, let's actually cat the temp packages curl and curl tcz dot. I just overwritten this. My bad. VICI pi. Yeah, I just did this wrong. So this, let's call this one the dependency, right? Quit pi curl, and now cat temp packages curl dependency file. So here we have the list of dependencies, well, or the only dependency for now, but again, there might be many dependencies, so yeah, just to give an idea. So what we need to do, we need to look over the entries within the curl.dep or whatever file we've downloaded to download all the dependencies, and if the dependency has another dependency, we need to download those and look up those as well. And that's where the recursion comes out of the stage, but we'll come to this a little bit later. And apart from this, we also need to make sure that the MD sum has been checked. So to deal with that, we also need to download the MD5 sum file. So again, yank paste. So this one is going to be called MD5, and here this is called md5.txt, right? Quit and CURL. Oh, no, it's not there. It's not there. Yes, it's not there. CURL. Okay. So now let's get the temp packages CURL MD5, and we have the verification key, integrity key here that we will be using when we would be running the MD5 sum command. Okay, so the next step is the following. Going back here, so now what we want to do, we want to change directory to the download and the name of the package that we've just downloaded. And also we want to run the MD5 sum and -c want to check, and we are checking for the file, the MD5 file that we've just created, that have just been demonstrated. And now this might be like whether it's okay or not. So to check for that, actually we can also do the cs -cs. Yeah, because we want to use the, instead of printing the error to the screen, we want to use the error code indicating things. We just ask whether the return code, the status code of the last command being executed, which is the MD5 sum. So if this code is not equal to 0, and if the code is not equal, if this is if the exit code is not equal to 0, this means that the error has occurred. So in this case, we just want to say exit 1, because the integrity check has been failed, so we're not doing anything further on. We could have add the message here as well, but yeah, since we would never fall into this situation really, so well, just for the demo purposes, I just don't really want this to get complicated. Yeah, and finally just fi here. But otherwise, if we go to the next line, this means that the integrity check is just fine. And in this case, we can define our dependencies. So I create the deps variable, and this would be the result of the execution of the following command. So here I say cat, and I want to cat the file with the dep extension. And this might happen that there is no such a file. In this case, we want to redirect the error, like we have the std, std out, std in, and std error. So 2 is the code for the std error. We want to redirect these to dev null, which essentially means I don't want to print anything to screen. Otherwise, we will indeed have the deps being initialized. And if we do, then we want to loop over those dependencies. But it might happen that there are no dependencies, and to check that, I can say if, and again, the same trick. So if the status code of the last command being executed is not equal to 0, in this case, I just want to say just return, and that's, by the way, the return condition from this recursive function. And fi, and if we didn't return here, then it means that there are dependencies. There is at least one dependency, so we can say for dependency in dependencies want to do the following thing. We want to call fetch recursively here, and whatever output of the command if we just echo and then echoing the dependency and feed it to the sed command. And under the sed command, we want to change we want to substitute the escaping dot tcz with nothing, because our fetch function doesn't take the argument as curl.tcz, just then takes the argument as curl. That is, we want to strip the tcz from the dependency. And again, the dependency is just the item in the file, so they are like every dependency starts from the new line. And this for dep in deps allows us to loop over the rows under the dependency files. So hopefully that makes sense. Okay, so this should already be actually it in regards to recursively downloading things. So let's actually give it a try. So right, quit, and I hold my breath, and I just try to say PICURL, and it should download both the CURL and the CA certificates, and it seems like it does that. So let's list the temp folder and the packages. Yeah, oh no, so sorry, alas. Temp folder packages. Yeah, we have the CURL and we have the CA certificates. So let's say we go to the CA certificates, and also we have things here. Yeah, CA certificates does depend on the CURL. Oh, hold on a sec. It's not correct. Okay, yeah, that's because, yeah, why did I do this CRL here? Yeah, it was just for debugging purposes. So obviously there should be the respective name of the package. Otherwise, yeah, I would be calling all the packages CRL, which is definitely not the case. And let's try again pi CRL, and let's have a look. So writing packages, then the okay, also does the OpenSSL, which is cool. So an OpenSSL should be the dependency of the CA certificates, I believe. So let me have a look at the temp packages. Yeah, we have the CA certificate, CURL, and OpenSSL. Yeah, why didn't OpenSSL appear in the dependencies earlier? Yeah, I don't know, probably messed up something. So anyway, let's have a look. So packages, the CURL, we have the CURL files, great. If we have a look at the CA certificates, we have the CA certificates files, and yeah, this one as well. And by the way, yeah, let's check the dependency for say cat CA certificates and CA dependencies. Yeah, so CA certificates do depend on OpenSSL, and that's the reason. So if we go to the OpenSSL, oh no, not here, OpenSSL, just list. Yeah, so OpenSSL does not depend on anything. So yeah, that's where the recursion exits from the loop. Okay, let's go back to our source code. And here I want to add another function, so I call it install. And like this. And also want to call install. Install doesn't take any arguments, so just being called, that's it. So the first thing to do, I want to say sudo and mkdirk, want to create the directory and parent directory if needed, add the user/local. So if it is there, great. If it isn't there, then I want to create one. Then I want to define the variable called packages equals to the output of the. So in case if we have the CURL, for instance, so this packs would be equal to CURL and then OpenSSL and then CA certificates. So once this is done, we can then loop. Oh, no. We can then loop over these things that we have there. So I can say for back in packs and want to do and done. And just to show you, maybe if I just say echo and pack, so to see all those packages that we have, right? Quit pi curl. So every time we delete packages, because we've explicitly asked it for that. So yeah, we have the CA certificates, the CURL, and the OpenSSL. So the next thing to do, we want to mount the tcz file, because tcz file is the squashfs file. And you remember we have compiled Linux kernel for the Monkey See Monkey Linux distribution exactly to support the squashfs file system, and that's the file system that is supported by the TinyCore on its own. So we will mount to the particular folder. So we'll mount CA certificates to the CA certificates folder, CURL to the CURL folder, OpenSSL to OpenSSL folder. And then we want to copy everything that is available under that folder to our user local folder. And that's how we can do the installation. So that's done as simple as the following. So I can say sudo mount, and then I want to mount whatever goes, like download, and then the current package, and then the name of that package .tcz. So that's the download, that's the mount target, and we want to mount this to the download and pack. So to exactly the folder so that we already have there. Then we want to copy recursively everything from this newly mounted folder, download and pack, and that would be the folder called user and local. That's specific to all the TinyCore Linux packages. So they all have the user folder, and under the user folder there is the local folder. And under the local folder, we have all the folders like bin, lib, share, whatever folders that we need. So we essentially need to synchronize those from the TinyCore Linux extension with the system user local. So from local, we want to copy everything to user and local that we've just created, and do it like this. And after this, we just want to unmount, so I say umount, and the download and the pack, and that's it. So we're just unmounting the squashfs after everything has been copied. And after this is done, we should already be capable of installing packages. Believe it or not, that's simple. Yeah, that's simple. So anyway, let's give it a try. So it would be a bit more challenging with actually installing CURL, because we'll need to manually update the CA certificates. So that takes time. We'll cover this a little bit later. But for now, let's try to install a couple of text editors. So let's try to install Vim. So I say pi, and just to give you an idea that I don't have Vim on this system. So pi and try to install Vim. So we download in the Vim itself and the dependencies for the Vim. Okay, we don't really need gvim base here because we don't have the X server. But anyway, so now if I did everything properly, this should run the Vim, and we do have the Vim, believe it or not. This is amazing, yeah? So let's just quit from here, and let's say pi installed NANO, okay? So downloads NANO and dependencies. NANO has more dependencies, and it has many nested dependencies as well. So now let's do NANO, and we have NANO being open as well. Okay, now let's try to install our CURL that we've been trying to do from the very beginning. And here, the interesting thing that if we just try to run the CURL with HTTPS, say example.com, it doesn't work because it doesn't see the path to the CA certificate. So we need to update those. If I say update CA certificates with a sudo, yeah, it tells me that there is no directory user local as SSL cert. So let's create one, sudo mkdir user local at and SSL cert. Let's create one and let's try to update again. Okay, now it does update, and now if we just do our CURL stuff, then it should work. Okay, great. And now what is the most satisfying thing, that we can actually install Git, believe it or not. Yes, so we can do like pi and Git. Okay, because Git does rely on the CURL. All right. So let's do now Git. So we are at the home folder. So let's say git clone https github.com and my username, and let's clone my text editor VICI that I've been demonstrating during this tutorial and the past tutorials as well. Okay. The internet connection sucks for some reason, so it goes a little bit too long, but yeah, anyway. And let's try to cd there. Okay, and cd to the source. Yeah, great. We have the VICI text editor here. So yeah, for instance, if we do just go back and let's open the our package installer. You see like FI is not highlighted, done is not highlighted. Well, because that's the outdated version of the VICI text editor that I've been using under the ISO. I need to update that, but just to give you an idea, that if I just do CP and VICI source and VICI, so it's already updated there. And I want to copy this to the bin VICI file exists. Well, yes, it does, but that's exactly what I want to do. Oh, maybe I need to do this with a sudo. Apparently, yes. And now let's try VICI PI again. Yeah, now see like FI is now highlighted, as well as done is now also highlighted. Yeah, so we just updated the VICI text editor by first cloning this using Git. And obviously we can push the changes as well, but yeah, Git token is needed for that. So, well, but that's no different from whatever Git experience you have on whatever Linux system. So I guess this is from my side with these two simple functions like fetch and download, fetch and install. We can download packages from Technical Linux repository and recursively resolve the dependencies, and then install things to the user local folder, and then we can run them under the Technical Linux. So this should also be the case for the for whatever literally Linux distribution. But the problem is with this approach is that if you do this, you can mess with the libraries. You can accidentally overwrite some libraries that you already have, which is not good. So it's not recommended to use this on your like normal Linux distribution. But if you're creating some customly compiled Linux distribution from scratch, in that case, this package installer might be extremely helpful. So yeah, guys, this is from my side. Thanks for watching. I hope you found something useful within this tutorial, and I'll see you in the next video. Cheers.